Hi there, and welcome to our investigation into the case study of PFAS contamination across the Raft Basin in Williamtown, Australia. Our team members include Harris McLaughlin, Daniel Nikolic, and Elle Oakman. PFAS, or per and polyfluoroalkyl substances, are a chemical found in products with the ability to resist heat, water, stains, and oil. The provided picture only shows some of the PFAS sources in households. The main adverse health effects to humans were found to be reproductive and development issues, effects to the liver and kidneys, and breaking down of the immune system. The Raft Basin in Williamtown has identified PFAS contamination, and with our investigation, our team will be able to provide a remediation technique recommendation that is suitable for these sources of PFAS contamination.
The Royal Australian Air Force, or otherwise known as RAF, Raft-based in Williamtown, is located 15 kilometres northeast of the city of Newcastle. Nearby the RAF base, we have the town of Saltash. The key aspects surrounding the RAF base is we have Moore's Drain flowing into the Tilligary Creek system. The Tilligary Creek system runs by Saltash and goes out towards the sea. On the western edge of the RAF base, we have Dawson's Drain, removing all the stormwater into Fullerton Cove. Nearby the RAF base surrounding, we have many different swamps, like Long Bright Swamp. All these waterways allow for PFAS contamination to expand. As we see by the blues in this graph, we can see the PFAS plumes expanding along these waterways. The RAF base Williamtown opened in 1941 and is also combined with the Newcastle Airport. There's many different assets on site, and they consist of Fire Station or Air Services Australia, aircraft hangars, aircraft maintenance areas, and multiple runways. The base itself is the home to the Air Combat Group, squadrons, and the wings of the Royal Australian Air Force. PFAS in firefighting foam, or otherwise aviation fluids, was used since 1970s to mid-2000s. Historic records noting on-site storage disposal is unknown. With the unknown records of disposal and storage of PFAS in firefighting foams, testing is required over the whole site to determine high areas of contamination, etc. at the fire station. There's some geological impacts that we need to be aware of for RAF base Williamtown. It is located in the Tomago Sandbeds aquifer, covering approximately 8%. This aquifer supplies 20% of the drinking water to the Hunter region for uses for domestic, commercial, and agricultural uses. This could mean health impacts to the community or impacts on the food supply chain in the local area. The main contamination off-site is PFOA and PFOS, which is the main chemical group in PFAS firefighting foam. Contamination has been seen near these waterways, such as spoken before, Dawson's Drain, and nearby Nelson Bay Road. We're seeing some high levels of contamination in the soils. Surface water and groundwater, especially close to the base, we're seeing extremely high levels of contamination.
In 2018, there was a parliamentary inquiry regarding the practices in training exercises and the use of PFAS chemicals from 1980s onwards. The inquiry, which cost $130 million, was conducted over a cumulative area of 1,150 square kilometres. All locations were RAAF or Army Aviation bases, most inland and some coastal like our subject site. 3 additional sites were chosen as a case study for costing, alternate remediation strategies, or just being a close comparison in scale and the methodology of our subject site. Tyndall in the Northern Territory was chosen for its use of a new product in immobilization and absorption methods. The HMAS Albatross was a comparable coastal site in Nowra. And the Army Aviation Centre in Oakey, Queensland was chosen due to the scale and variety of remediation methods used. Ex situ methods were dominant in all sites, and the degree of which was dependent on the spread of PFAS through aquifers, the proximity and contamination levels of local neighbouring towns, and the effects on subcatchment areas, usually spreading over several, such as the coastal sites. The management area map shows us that the required water treatment, earthworks, areas needed for barriers and extractions of soil and groundwater, these were provided by the Department of Defence in a very comprehensive report. Tyndall required more groundwork but had more concentrated zones for water treatment. Williamstown existing strategies required the most water treatment and earthworks, and it's reflected in the costing. The Army Aviation Centre is to be noted to having one of the smaller areas of effect, but a large amount of contamination and soil management was needed on the site. To create estimates accurate to each respective site, the first step was to use mapping tools. The government websites listed were used to calculate areas overlaid by the management plans using AutoCAD to measure the areas. Each type of remediation used was then associated with its respective area of effect, and projected costs were taken. Where we were only given a range of cost, we took a conservative approach and used the maximum value of the range given. The table above, it's for our subject site as the already existing remediation strategies. From there, a total cost can be calculated and a figure finally given in the form of cost over area. This method was applied over every case study and the existing remediation strategies for the subject site. Then location cost factors were used from the Cordell Guide 2020 and respective sources for both Queensland and the Northern Territory site. The aim of this was to increase the accuracy of the costing, given that most of the methods we were given were in the form of a range, and we wanted to apply an extra degree. From here, when we applied it to our prosed and adjusted strategy, we can multiply the respective costs once again using the local adjustment factor, in this case for Newcastle, and increase the accuracy of our costs. What we found from our results that ex situ methods, especially the extraction for both the soils and water, was the most expensive options. Cost tied to this remediation methods was due to on-site or off-site detention or disposal and the scale that was needed to conduct them. Treatment wasn't always possible depending on the level of contamination, and a few methods were used. Although the management plan suggests that there was a few methods that were considered, but they were in the infancy of the research phase. One method stood out because of the scale of the earthworks, and it was the immobilization and absorption methods using a compound called Rembind, a additive with clay and carbon components, and it was used in the Tyndall RAAF site. This reduced the disposal costs of the earthworks, which made it significantly cheaper by a reduction of area used. Their publicity documents on regarding Tyndall promoted Rembind as an affordable and ecologically friendly solution, and it is evident in the costing.
PFAS remediation needs to be put into two categories: solids and surface or groundwater. PFAS contamination remediation strategy chosen for solids is soil flushing. Soil flushing is where water or aqueous solution is added to the soil to flush the contaminants out. But with PFAS, the soil and solution need to be collected into a hydraulic containment. Our recommendation for PFAS contamination in surface or groundwater is extraction, an off-site treatment of affected water with the added use of an ion exchange resin for the PFAS contamination. It is best for maximising mass removal of the contaminant, and the treated water can be tested and reused for other processes or reintroduced back into the local water system.
Throughout the course of this research project, we've come to have a better understanding of PFAS and chemical contamination in general. how once spread through the aquifer, the severity of the situation which has caused, especially in different topographies that we've seen in the case studies, and different effects. We can see how the different sites produce different strategies and therefore cost things, and how further technologies such as additive agents can reduce or increase the costing depending on the site. We were able to formulate our own remediation strategy with little variations on the existing, but we were able to see why certain methods, regardless of cost, were tried and true. So thank you very much for your time. Bye-bye.